Um, okay, yeah. So, I met someone in at PharmaPack in Paris, and we were talking about some of your offerings, and he mentioned the green propellant, which is really interesting. I don't know a lot about propellants, so I was surprised that there even is a green offering. So I thought we could kind of start with, what makes it green? How does it differ from traditional propellants?
Yeah, yeah, for sure. So, in a meter dose inhaler, the propellant is the vast majority of the formulation itself. Somewhere between 90 to 95% of the
Hmm.
actual formulation is propellant. So that's the bit that turns the API into a mist that the patient can inhale and then deposit the drugs into the deep lung area. So that's why propellants are really important in meter dose inhaler. It's almost like the engine to
Yeah.
deliver the drug to the lungs. Um, a lot is happening with propellants in the industry at the moment, but it's not new territory because what we're looking at now is a transition away from I guess relatively bigger impact on the environment propellants to propellants with a lower impact on the environment. But back in the last century, sounds so long ago now, but in 1987 there was a piece of legislation that was agreed to by most of the world. I think 190 countries signed up to the Montreal Protocol, which effectively banned a class of chemicals called chlorofluorocarbons or CFCs. And what they
Okay.
were to was a hole in the ozone layer, particularly above the Antarctic and the Arctic. So there was a lot of legislation put in place to phase down and phase out chlorofluorocarbons from both industrial use and medical use and general use in any particular in any application worldwide. So that was very successful because actually the ozone layer did recover. I don't know if it's completely recovered, but certainly it reversed
Hmm.
something that could have been potentially catastrophic for the environment. So what's happening now is that the chemicals, the propellants that would replace CFCs, so that was HFAs or HFCs, which stands for hydrofluorocarbons or hydrofluoroalkanes. Now they are deemed as what's called greenhouse gases. So
Okay.
so they have a detrimental impact on the environment that it promotes global warming. These class of chemicals promote global warming. So here we are again. There was an amendment to the Montreal Protocol signed in, I think it was 2016, called the Kigali Amendment, where again the signatories of that particular legislation agreed to phase down and eventually phase out HFCs. So the current propellants on all MDIs are HFCs. So now we're going through another
Hmm.
transition period to swap those current propellants into propellants with significantly lower global warming potential GWPs. So that's really the environmental credential, and that's why we kind of call it green propellants or
Okay.
generation propellants or low GWP propellants. Take your pick from all of those three.
Okay. Now, is the whole industry going that way? That is that the mandate, I guess I should say. If I'm an inhaler manufacturer, am I choosing to do this or this is where I need to go?
Depends where you are located in the world. So
Okay.
different countries will have a different interpretation of how they will implement the Kigali Amendment. So in Europe, for instance, that is the group of countries that is heading into transition before anybody else. So the
Okay.
European F-gas legislation has been enacted, and that'll come into play 2027 through 2029. So there's a 3-year transition period where effectively you're going from the current volumes to at the other end of transition, the volumes allowed on the market will be about 20%, so about an 80%
Hmm.
reduction. UK now we're not in the European Union, can choose to legislate on its own F-gas, but right now the meter dose inhalers has got a derogation, so it is exempt from any F-gas legislation. Um, The US, it depends. In the US, there is a Californian state legislation which phases out by, depending on the propellant, 2030 or 2032. But that's not all of US. So it's been interesting to see what happens in the US. And I guess it all depends on the administration and their view of
Sure.
environmental topics as well. So there's no answer to that because and then countries that I've
Yeah.
not mentioned, they've got to phase out by 2050, and they may choose to follow suit to some of the European, maybe Australia and Canada may look to see what's happening in various different markets before legislating themselves. So it's a mixed bag, really.
Okay. Yeah, it sounds like it'll vary significantly depending on region, which is sort of how the industry is with other regulations and rules. So
It is.
not too surprising there. Um, so how does the manufacturing differ or the packaging? Does that affect the packaging at all when we talk about using these different propellants? Is there any adjustments that need to be made?
So I mean, it's all connected. I mean,
Yeah.
fundamentally, what we do have is the two propellants that are replacing the existing two propellants have very different physical and chemical properties to the existing ones. I mean, physically, there's a density change as a one obvious example, which does have an impact on the formulation itself. So it's just not a simple case of plugging and playing a different
Hmm.
propellant. I mean, I think this is already affecting industries like air conditioning units, where you can drain an air conditioning unit with one propellant, then put another one in, and probably expect to have very similar results. Well, pharmaceuticals is a very different world altogether. So you have to make sure that there's no problem with putting a new propellant. You've really got to redevelop the product from scratch as if it was a brand new product. Um, so that's in the development phase. Clinically, well, different regulators have different views on that, and very much this is an active area of discussion at the moment. So, for instance, the European Central Agency, the EMA, is very clear on what it needs from a clinical perspective to approve products in the new propellants. I think FDA's thinking is still evolving. Their consideration of whether these are brand new products and need full PK and PD studies, or whether there's more in vitro data required rather than the full clinical data. So it is evolving, but the assumption that everything stays the same and all you're doing is changing a propellant is not the case.